Okay, welcome back. Chapter 26, Quiz B, question number 2. We know Chapter 26, we're studying the chi-square statistic. And chi-square allows us to make inference for categorical variables. In the last two videos, we learned that if we have a one-way table, we are going to do a chi-square test for goodness of fit. Again, if we have a one-way table, we are going to use the chi-square test for goodness of fit. Clearly, in this prompt here, we have a two-way table. We're comparing two different categorical variables, and they are whether or not a part has been rejected and vendor. Okay, so when we're looking at a two-way table, we are going to either use the chi-square test for homogeneity or the chi-square test for independence. And as we read the prompt, I think we'll be able to tell which test we're going to use. Mathematically, both tests are the same, and in order to calculate the degrees of freedom, the degrees of freedom is given by the expression r minus 1 times c minus 1, where r is the number of rows and c is the number of columns in our table. Okay, so let's take a look at the prompt. A manufacturing plant for recreational vehicles receives shipments from 3 different parts vendors. There they are right here, Perfect Parts Company, Made for You Company, and 25-Hour Parts Company. There has been a defect issue with some of the electrical wiring in the recreational vehicles manufactured at the plant. The plant manager wonders if all of the vendors might be contributing equally to the defect issue. The plant manager reviews a sample of quality assurance inspections from the last 6 months. The data are shown in the table below. Test an appropriate hypothesis to decide if the plant manager is correct. Give statistical evidence to support your conclusion. Well, first we have to figure out which tests we're going to be using. And in order to do that, I think we have to have a discussion about the word homogeneity. The word homogeneity means things are the same. In this question, we are asked, are the defect issues the same among vendors? This is a test of homogeneity. When we have a test of homogeneity, our hypothesis is always the two categorical variables are the same or homogeneous. Okay, so our null hypothesis is always going to be that the two categorical variables, or the number of rejected versus not rejected, is the same amongst all the vendors. Okay, so let's take a look at that. Oh, wrong slide. Your mother's nephew's brother's uncle. Okay, so you see here that our null hypothesis is the type of defects in the vehicles made by the 3 vendors has the same distribution. They're homogeneous, so it doesn't matter the vendor. The types of defects seem to be the same. Okay, the alternative hypothesis is the type of defects in the vehicles made by the 3 vendors do not have the same distribution, meaning maybe one vendor has more defects than the other. Okay, so when we are doing a chi-square test for homogeneity, our null hypothesis is always saying our two categorical variables are the same. Okay, in this case, have the same distribution. Okay, that's always our null hypothesis. So as always, before doing an appropriate hypothesis test, we have to check our conditions. For the chi-square distribution, we have a couple of conditions. The first one is counted data. The counted data condition. We have the counts from a sample of quality assurance inspections from the last 6 months. So check, that has been taken care of. Let's see if I can move this as I speak. All right, so our counted data, I can actually get rid of that. The next condition is randomization. The data are from a sample of quality assurance inspections from the last 6 months. And hopefully we randomly selected from that sample. Okay, expected cell frequency. The expected values, which I blacked out actually, they are in underneath these rectangular regions in the table, are all greater than 5. And believe me, they are all greater than 5, and we'll check them in a minute. I just wanted to talk about how we're going to calculate our expected values. Okay, so under these conditions, the sampling distribution for the test statistic chi-squared is 3 minus 1 times 3 minus 1, or 4 degrees of freedom. Okay, so I'd like to take a look over here. This is my calculator sequence. So I'd like everybody to grab a calculator. I would like you to hit your matrix key, which is second inverse of x, and you should get a matrix key that looks like this. Okay, and I'd like you to arrow over to edit and then hit enter. And in matrix A, you're going to change it to a 3 by 3 matrix, and it's always number of rows times number of columns. There are 3 rows, 1, 2, 3, and 3 columns, 1, 2, 3. So please change your matrix A to a 3 by 3 and enter your data accordingly. Okay, so here's my data in my calculator. I'll give you a minute to enter your data as well. Okay, so this is a chi-square hypotheses test. Okay, so if you go over to Stats, arrow over to Test. Okay. You will see chi-squared test. Notice directly underneath is chi-squared goodness of fit test. We only use this test if we have a one-way table. Therefore, we're going to use chi-squared test. And this is the test that we use for either chi-square test of homogeneity or the chi-square test of independence. So we're going to hit enter. Let's see. And when we hit enter, we see that our screen looks like, our screen, what happened? There we go. Sometimes I grab both at the same time. Our screen would look like this. Our chi-squared test, our observed data is in matrix A. Our expected values, the computer or the calculator is going to calculate and place them in matrix B. That's where these numbers under the hidden rectangle is going to come from. Our calculator is going to compute them. Okay, so we just hit enter, enter, enter. Let's see. And we should come up here with our chi-squared statistic. Our chi-squared statistic has a value of 7.40. It has a p-value of 0.116. That is a high p-value. Our alpha level was not given, so we know that we would assume an alpha level of 5%. 11.6 is higher than 5. And we know when our p-value is high, we have to fail to reject the null hypotheses. Our degrees of freedom is 4. Okay, so you're going to see that this information over here is going to match what we have calculated in the calculator. Okay, so the probability of our chi-squared being larger than 7.40 is approximately 11.6%. That is a high p-value. And again, with a high p-value, we are going to fail to reject the null hypotheses. And this means there is little statistical evidence to indicate that the types of defects vary by vendor. Again, a high p-value tells us we failed to reject the null hypotheses, and there is little statistical evidence to indicate that the types of defects vary by vendor. I'd like to go back and I'd like to show you how to get the expected values in your calculator. according to this step right here, it said our expected value should be in matrix B. So if you could hit that second matrix key again, or it's the second inverse X, so that we get matrix B, arrow over to edit again, and arrow down to B, and you should get these values in matrix B. And what do these values represent? They represent our expected values. So if you take a look here, these numbers here match the expected values that are in my table here. And I'd be happy to show you mathematically how we got these values. It is important to have the expected value because you might be asked to compare the chi-squared components in the future. And we know to find a component, it is observed value minus expected squared divided by the expected value. We did that in our last video. Okay? Excellent. Turn in again. Miss Max Academy.